afternoon, evening to you, students. How are you tonight?
Good evening, sir.
Welcome.
Good night, sir.
And how are you? Oh,
Not much, sir.
you're back.
Yes, sir, I'm back.
Yeah. Nice. Welcome. All right. I'm seeing you trying to come in. Let me see. Questions here. Questions here. After interesting. Okay. All right. So, okay. Let me just get rid of this. All right, sorry, I was getting an echo because I had two devices in, so it took me a while to get it off. All right, so welcome. I good to see you again. Kels, nice. I hope you were able to get the notes for what it is that we did, and are able to keep up to track. I am going to have a review. I'm going to have a review of what it is that we did on Tuesday. This because I got a request, sir, not fully following what is happening. Let me see, hear from you. Are you following what it is that we did last class? Is there anyone with a grave difficulty in what it is that we did? When I said grave difficulty, it means saying a lost, don't have a clue what they're talking about. Is there any such person in the group now? And don't be afraid to speak the truth and talk up to me. It's a family, and I want to know, so I can know how to treat it. Say that, Krishna?
I came in late, so I guess me.
Okay, you came in late last class. Yes, you did. All right.
Sir?
Yes.
Well, you know, so me did out for a while, but me did plan to me and you I go sit down on the weekend. And me go listen to your voice.
Oh Lord, I miss your humor. I thought you were gonna say me, you, and the whites, but never mind. Sure, we can do some plans for some makeup. A few students were asking.
No, sir, me I thought about your recording, you know. If I'm missing me and you.
Yeah, man, a voice, yeah, man, I get you, man. I get what you're saying. I'm just saying by extension, a few students were asking about that session I spoke about earlier. I mean, when I said earlier, like after the mid-semester, because because some people were saying that, you know, they're not fully understanding what is really happening. So the aim is not for you guys to be lost and know that you guys are lost and I'm not assisting you. That's not the aim. The aim is for me to facilitate you as best as possible. Towards the end of the class, I will have a conversation, just wait for others to join. Towards the end of the class, I'll have a conversation to see which day I could possibly get a 1 hour. I know you guys work, and I know you come to school in the evenings, but anyway, we will talk. Something just came to mind a while ago. That's why I said that. Let me just say it now then, since it came to mind. Remember that exams will be I think the last week of January into February 11th. Oh Lord, help me. What did I see on that paper? Yes, I think it starts the 31st.
Right.
Right, the 31st of January up to the 11th of February. Right. So consider that we have a month, because I'm aiming we'll go off on the 17th of December. That's when school ends. So I will have my last class with you on December 16th. All right, have my last class with you on December 16th. By then, I should be finished with, well, definitely I'm going to be finished with the integration, and I should start and finish the applications of differentiation and have that little one topic left, that little last topic. I should be able to start with you the final topic for the calculus one before we close off on the 17th. What am I saying? We will have a good month to do some review. When I say a good month to do some crash course, crash work, and try to get things in order so it is that we can maximize what it is that we've been doing. We were blessed to have started in September, and we're even more blessed to get an extension of the semester. So you are getting more than the 60 hours, or will be getting more than the 60 hours. So I'm hoping that time will be beneficial to you. I teach most evenings, including a Saturday morning from 8 o'clock to 12 o'clock. So let us see how it works out. Let us see how it works out. Let us see how it works out. I should check that recording. I think I have. Okay, I did a voiceover for a class in last semester. I'm going to share that voiceover with you guys. I think it was on integration, and I think that voiceover will make a lot of sense. All right, that's so log into my YouTube and check it and see if it is for integration. Yeah, and then you guys can listen to it. All right, so for now though, we went through some laws. Now, what is important now, guys, and I want to get me, and I'm not trying to be cheeky, but I'm just being very open and honest with you. I don't want anybody to tell me, say, sir, me not understand. You can go over for me, and then in the same breath, you're going to say to me, oh, sir, I don't get the chance to listen to the recording. It defeats the purpose of me trying to send the recording to you. Matter of fact, I didn't send the last recording, don't. I did? No? Yeah?
No.
Okay. I was looking for the recording to come to me, and then I didn't see it, and then I need to check it again.
No, sir, you didn't upload it.
Yeah. Thank you, Sean. All right. So I don't want, and I mean, I'm being the nicest guy on earth right about now. Say to me, sir, I have gone through the recordings. I'm still having a challenge with something. Don't tell me, say, sir, I don't understand. You have the recording, you have the class right there. Go through the something, and if you still not understand, then you come late and say, boy, sir, here the plan. You just say this at 1 hour, 20 minutes, and 14 seconds. This is something I may not understand this. Let me go back and look and see what I say, and then explain to you. But I don't want you to sit down and not do the work. I told you already how to go through. When you listen to the recording, say, oh, them could talk up, you don't have to listen to this. You fast forward it to get the notes, what it is that I'm showing you. All right, and then you should be fine. Remember, I have 21 of you in my class, and when I mark and press equal, I need to say 21 passes. All right, and I also going to say to you, I don't do C's well here. I really don't do C's well. So try and make sure, say, the lowest grade that I'm seeing on paper is a B minus, right? Even if it's on the string, you're going to hold on to the B minus compared to the C plus, hold on the B minus. Get the 65%. All right? I don't want no 64% because I C plus that. All right. Only to stop me to the point. All right, so we looked at integration and we gave you about 8 rules of the integration. And one of the things that we did in class last is that people were seeing what it is that Sir did. And Sir was going through, and Sir went through, and people were saying that, Sir, I never did mine in so many lines. But the truth is, I don't expect it to do it in so many lines. All right? And this computer is playing with me. Okay, so when we're integrating, remember we add 1 to the power and divide by the new power. When we're integrating, we add 1 to the power and divide by the new power every time.
Are you sharing?
I'm not sharing it. I know the system is taking its time to come up, so I just talking while it comes up. So when you're integrating, you're adding 1 to the power divided by the new power. Thanks for the info. You're adding 1 to the power divided by the new power. Adding 1 to the power divided by the new power. So that's all that there is to do. But there are some conditionalities to it. No, I'm sharing. So there are some conditionalities to it. There are some conditionalities to it that if, when you are integrating, for example, 1, we don't write 1 dx, we just simply write dx. And when we integrate dx, we're going to get x. Always remember that. When we integrate dx, we're going to get x. Sir, why? It is so because when you differentiate x, you get 1. When you differentiate x, you get 1. When you're integrating, you're adding 1 to the power and dividing by the new power. So x to the n is going to be x to the n plus 1 divided by n plus 1. You're adding 1 to the power and dividing by the new power. It's very important that you remember this. This is the real deal. What is also important is that when I'm integrating a constant, I can just go ahead and one of two things. I can either take the constant out and put it in front of, because that won't change. And then now I integrate dx this way. Look, watch this. So this constant, the integral of a constant is going to be the constant with an x. But when I'm integrating here, this constant I can remove, and you'll see that rule sometime later. I can remove this constant and put outside and just integrate dx, which is this. Watch the sequence. That's what my here. I'll go come over here. So what I'm going to have right here, so is just integration dx, the integral sign dx, which is this. And then I'm going to get x plus c. Then no, when I multiply the k by the x plus c, I'm going to get kx plus kc. But kc is just still a c. Any multiple of the constant of integration is just the constant of integration. And a little later on, you see that again in one of the questions. When we look at c, when we integrated the individual terms, I've got 5 c's adding together, you can see also a big C. It's the same c if you did everything as a whole. All right, just remember, you go to the supermarket and buy 5 items and you pay for 5 items separately. The GCT is going to be in tranches. It's going to be little bit, versus when it is that you look at the calculation of all 5 items all at once. we're going to have just one big GCT. All right. So those are the first three. Then there's another conditionality. The integral of x to the minus 1. Whenever you see x to the minus 1 or 1 over x, you know you have to press pause. Why, sir? You have to press pause because that's going to be the ln function. It's going to be ln x plus c. Sir, then what do you mean by that? Then what if x was 2x plus 1? No problem. It is going to be 2x plus 1. It's going to be ln 2x plus 1. And then that 2x plus 1. What am I going to do with 2x plus 1? Let me see if you remember. What will I do with the 2x plus 1, class?
You're gonna
Add
add
one to
one
the
to the
power and divide.
We remember, you know, we're doing the ln function, you know. Would have done that for up here, but we're doing the ln function. I just said a while ago, 2x plus 1 to the negative 1. So what am I going to get? I'm going to get ln 2x plus 1. Talk truth.
Yes, sir.
What else do I do? I told you the last class. What else do I do?
The absolute, we're supposed to use the absolute value.
Not well, you can use the absolute value, yes. You can use the absolute value of 2x plus 1, but there's something else I need to do with the function.
At this E, sir.
Something else.
At this E.
Oh, my, something else. Something else. Yeah, something else. Something else.
You write it.
Let me see. All right. Maybe I was in my dreams, dreaming about the class. Maybe I was in my dream. And I said it to you because you're the only group I'm teaching integration, and I know I said it. All right. So what I'm going to say to you is, and you can let me know whether or not I said it. You can let me know whether or not I said it. That you're going to that you're going to differentiate the function. You're going to differentiate the function, the 2x plus 1, and you're going to reciprocate. Anybody remember that?
No, sir.
All right.
No, sir.
See, try yourself again too. See, try yourself again. You can differentiate here and then reciprocate the differential. This is where I spoke about it. Because they know that the ln function and the exponential function are related, don't? One is the inverse of the other. The inverse of ln is e, and the inverse of e is ln. So the logarithmic function and the exponential function are cousin. One is the inverse of the other. So just like how differentiation and integration are cousin, first cousin. Yeah, same with the logarithmic function and the exponential function. All right. So the inverse of one is the other. So let us look at it now. So let me not even go there. Let me just stick with this one. Right. So you're going to look at the absolute value. And why did we use the absolute value again? Let me see if you remember. Why would we include the absolute value for the question?
Because you have a negative.
Very good. And what about negative numbers and logarithms? What do you know?
It's going to I don't remember, sir.
You look on the screen and it did man. You cannot take the logarithm of a negative number.
Of a negative number.
Right. Good. So because you can't take the logarithm of a negative number, when you do some questions, and especially when we move into differential equations, we are going to use the absolute value sign because we can't take the logarithm of a negative number. And when we use the absolute value, it means that our number is always positive. What do you mean by that, sir? Suppose I have -1. The absolute value of -1 is +1. Then, sir, what is the absolute value of +1? +1. What is the absolute value of -15, sir? It is +15. Okay, got you, Krishna. Thank you, Papa. Good evening, Yannick. All right, so remember now, we will talk about that one. when we look at the absolute value of a number, the absolute value of a number is always going to be positive. The absolute value of a number will always be positive. So if you get a negative answer there, you just find the absolute value of it. It says a condition x has to be greater than 0 is added only because positive numbers have logarithms. All right, for negative numbers, we are going to be using the absolute value of x. And then rule 5, we went into the integral of the natural exponential function, e to the x. Now remember, I said to you the differential of e to the x is e to the x. I said to you that the differential of e to the x is e to the x, and then again times it by the differential of the inside. Now, let us jump ship. Integration. The integral of e to the x is also e to the x. Then, sir, you're saying to me that the differential of e to the x and the integral of e to the x is the same e to the x? But guess or no? Just like for the differentiation, the differential of e to the x is e to the x, and then you're going to times it by the differential of the function. This one, you're going to take it one step more. The integral of e to the x is e to the x. You are going to differentiate the function just like you did in differentiation. The only thing you're going to do different now is that you're not going to write the number in front of the function. You're going to write the reciprocal of the number in front of the function. And that is the only difference between the differential of the exponential function and the differentiation of the exponential function. Let me say that again. And I want you to listen. Don't blink. And turn off the fan so it don't blow away the information. When I'm differentiating an exponential function, the differential of the exponential function is the exponential function itself times the differentiation of the function. That is, what is the differential of e to the 5x? The differential of e to the 5x is e to the 5x, but I'm going to times it now by the differential of 5x. And the differential of 5x is going to be 5. So my answer is going to be 5e to the 5x. Let us jump now to integration. How do I integrate e to the 5x? The integral of e to the 5x dx is going to be e to the 5x. Then I'm going to differentiate the function, 5x to give me 5. But I'm not going to write the 5 because if I write the 5, that will be differentiation. I'm going to write the reciprocal of 5, which is 1 over 5. And when I write the reciprocal of it and get 1 over 5, e to the 5x, then I would have integrated. Then, sir, you can check that for me, please. So let me see if it come back to the differential, to the differential of original stuff. Okay, no problem. The 1/5 is the constant. I'm going to take it out. Then I'm going to differentiate e to the 5x. When I differentiate e to the 5x, I'm going to have 5e to the 5x, as I told you before. Now, when I multiply 5 by 1 over 5, I'm going to get 1. So it comes back to e to the 5x. Were you able to follow that mental mathematics a while ago? Yes, no, maybe so?
Yes, sir.
Okay,
Oh, sir.
listen to me now.
Couldn't see that.
On a calculus students, you know. So when I'm supposed to can see my mathematics in the dark.
All right, let me see it now, sir.
Yeah, man, I'm going to put in on my connection so that I can. All right, I soon show you. Let me just go through the laws and then I'll come back to that one. Let me just finish off the other 3 and then come back to that. All right, so the integral of a constant times a function equals a constant times the integral or the antiderivative of the function. Remember, the integral and the antiderivative means the same thing, right? Antiderivative because it's so nicer. When you say antiderivative, you can know that it is the opposite to differentiation. But me like to use the word integral. So most times you hear me talk about integral. But if you go into the exam and see antiderivative, hello, integration. Anti, opposite. Integration. All right? So what this is saying, let me just translate this for you. What this is saying is that I'm integrating a constant times a function. See here? The integral of a constant times a function is going to be equals to the constant times the integration of the function. See there? Equals the constant times the antiderivative or integral, same thing of the function. Are the same thing, you know? So if you can't remember them right up here, but you can remember this, you're good to go. Are the same something? What this is saying is that the integral of the constant times a function is equal to the constant times the integral of the function, right? And I alluded to that up top here when I say when I have a k, we can take out the constant, integrate the function, and then times it back by it. Same difference. And this plus or minus one here now, it says the integral of the sum or difference of two or more functions equal to sum or difference of their integrals is equal to the sum or difference of their integrals. So if I have the integral of f of x plus g of x, it's simply going to be the integral of f of x dx plus g of x dx. All right, and must be integrating the function with respect to something. And if it is f of x, it must be the integral with respect to d of x. If it's f of r, it's going to be d of r. And if I'm integrating f of x using the bottom one now minus g of x, it's going to be the integral of f of x d of x. So the bottom one again minus the integral of g of x. We saw this, and students were saying then, sir, and me really expect to go write all of them lines, sir. So me was able to move from the top one to the bottom one. Okay, fair enough. Sir, promise me that I'm not going to lose the marks. That you really take up marks to them things, you know, sir. I promise you. That's how I want you to do the question. All right. The integral of the negative of a function equals to the negative of the integral of the function. It comes just like the one here. I'm factoring out the constant. So I'm calling the negative sign here a constant. I'm factoring out the constant. So that's exactly what it is that I'm going to be doing. All right. And then, sorry, let me. How does this look like that? Oh, why does this look like that? Interesting. Ooh. I'm trying to get some stuff ready for you guys. So bear on with me, please. All right. Okay. So I need to share this screen now. So what I was saying to you, is wow, sleep up nice tonight. It's rain. Yeah, man.
You're not gonna sleep.
Talk truth. All right, let's go. So if I have, and this thing's not lighted. All right, if I have the integral of 5 to the x dx, all right, what I'm saying to you is the integral of e to the x is e to the x. So when I integrate that, I'm going to get e to the 5x. I'm going to get e to the 5x. But when we are differentiating, we would say times the differential of up here, and the differential up here is times 5. But for integration, it is going to be times the reciprocal of the differential, which is 1 over 5. So it's times the reciprocal of the function, which is 1 over 5. And of course, I'm going to have my plus c. I'm going to have my plus c. Hold on a minute, please. All right, so it's going to be, remember, you're supposed to have your plus c. All right, now, so when I put that together, what I'm going to get is going to be 1/5. Okay, my thing decides tonight that it wants to. I put on my gloves to see if it makes a difference. 1/5 e to the 5x. 1/5 e to the 5x plus c. All right, and this here would be my answer. That would be my answer. All right, now look at what I want you to recognize. If I were differentiating this function, if y is equals to e to the 5x. Oh, come on, thing, don't be playing with me tonight. If y is equals to e to the 5x, and I'm finding dy by dx, I'm going to end up with e to the 5x times the differential of the function, which is 5. So dy by dx is going to be equals to 5e to the 5x. All right? That's what the differential is going to be equals to. Now, the difference here, you know, the one is 1/5 e to the 5x, and the other one is 5e to the 5x. For the integration, we reciprocate. For the differential, we don't. For the integration, we reciprocate when you're doing the exponential function, right? Differentiation, we do the same thing, you know. Watch me again, for those of you who missed it. The integral of e to the 5x dx, I'm going to differentiate the function. The differential of e to the 5x is going to be e to the 5x. Sir, why? Because sorry, not the differential. Yeah, that is correct, but I'm not talking about differential. What I said just now is true, but it's not differential I want to talk about. It's integration. The integral of e to the 5x is e to the 5x times the reciprocal of the function up top. The differential of e to the 5x is e to the 5x times the differentiation. So one of them are going to reciprocate the differential, and one of them are not going to reciprocate the differential. And the one that I will reciprocate is going to be the integration, and the differential I don't reciprocate. All right? Now, to check my answer, I am going to be, incidentally, so when you integrate, what it is that you're finding is the origin of the function. Look here. So if I say y is equal to 1/5, oh Lord help me, 1/5 e to the 5x, I'm going to differentiate. Dy by dx is going to be equals to the differential of e to the x is e to the x. Matter of fact, let me do it as a product, because I want you to see what is happening. So I have this as the first, and I have this as a second. So it's going to be the first times the differentiation of the second. I'm differentiating the second. When I differentiate the second, it's going to be e to the 5x times the differential of the function, which is 5. So it's going to be times 5. So the first times the differential of the second, right back to e to the 5x. Then I'm going to talk about the differential of the function, which is 5, plus the second, e to the 5x, times the differentiation of the first. And when I differentiate 1/5, I'm going to get 0. So it's going to be times 0. So what you recognize here is that this portion of it goes to 0. That portion goes to 0. So all I have left is going to be dy by dx is going to be equals to 1/5 times 5 is 1 e to the 5x. E to the 5x, which is equals to e to the 5x. And e to the 5x is where we started. So when you integrate the function and you get your answer, and you differentiate your answer, you're supposed to get back the original function that you started off with for the integration. Remember, I said that one is the reverse of the other. So I'm showing you how the differential of the exponential function works in tandem with the integral of the differential of the exponential function. Let me say it one more time. The differentiation of the exponential function is going to be the exponential function itself times the differential of the function up top, times the differential of the power. So the differential of an exponential function is the exponential function itself times the differentiation of the power, compared with the integration of the exponential function. When I'm integrating an exponential function, it's going to be the exponential function itself. Sir, that is the same as the differentiation. Yes. Then, sir, you're going to differentiate the power. True. Very good. And what are you going to do with it now? Are you going to multiply the differential by the function? No, sir, you're going to reciprocate it. So you have 3 steps when you're differentiating an exponential function. Step 1, the differential of the exponential function is the exponential function itself. So you're going to write by the function itself. Then step 2 is that you're going to differentiate the power. When you differentiate the power, the answer you get is going to be step 3, where you multiply it by the function, the exponential function. In integration, the integral of the exponential function is the exponential function itself, just like the differentiation. So you can write by the exponential function. Then the second step is to differentiate the power. The same steps are like the differentiation. Very good. The third and final step is not to multiply the differential by the exponential function itself. But what you're going to be doing is multiply the reciprocal of the differential by the exponential function. So one of them again flip, the other one is not flipping, but you're doing a multiplication. So they are very closely related. These are brother and brother Pitney, or sister and sister Pitney, or sister and brother Pitney. This is not no cousin where you say you win some grand prize and everybody start your cousin. No, these are mother, father, Pitney them, right? Very, very close, blood chunk, all right? So you have to be very careful of that. Sash, you were the one who said that you have seen it. Are you seeing it now?
Oh,
I think, yeah, man, I think I overkill it, but I just want to make sure that you guys understand it.
I had a question in my head. I don't know if it's foolishness I'm thinking about, but what if you have what that S looking thing look again? Integral, sir?
Integration, yeah.
With ln e to the 5x dx.
All right. So you're gone like about 5 steps ahead of me. So I just going to ask you to just sit down on the bench little and wait until I catch up with you.
No, sir, I just think more that, you know, sir.
Yeah.
Never know, it makes sense.
Yeah, man. I'm if I tell you. Yeah, man. You can have. That would be. You can have it, whether or not it's on what it is that we're going to be doing is another thing. But you will see questions looking very close to that. Yeah, man. It's possible, man. Remember, you know, math is life. Math is life, and sometimes this life serves us with some dishes that are really not palatable to us. It's like you cooking susumba and give me, who you talk to? No deal. You may not eating it, right? But there are others who their life is just as bitter as that. And they have to eat the bitterness because that's just their reality. All right. So I'm saying to you, math is just like that because you have these complex situations that you have to solve to get a solution to it. So yes, you can have things looking like that, dearest. Trust me. Don't look pretty, but yeah, man. All right. So we looked at some questions, and you know what I want to do? You have those questions already in the document that I sent. You have those questions in the document that I sent. So what I'm going to do is, if this thing will work with me, let me just convert this into tonight's notes. I'm just going to generate some questions as we go along. So bear on with me. I'm going to try and make this thing as, you know what? I'll put you down here because you will give me problem in no problem in the narrative. So. All right. So we're gonna have a do now. Oh Lord, Father, come against this thing here. We're gonna have a do now exercise, eh? And the exercise is this. I'm gonna give you some functions, and I'm gonna ask you to integrate. 4x squared plus 7x to the 5th minus 6x plus 2. All right. I think this thing. I think this tablet may be a little dusty, which is why it's jumping up and down. So do me a favor. Want to work on that in the meantime for me, please? Let me just go and see if I can clean up this thing a little bit, please. Thank you. I'm going to mute. Come on. Anybody finish?
Yes, sir.
Nice. So watch me now. Go to bam. And let me do that. Add 1 to the power, divide by the new power. 4x squared. No, what is wrong with sir? You know, say in time, it look like in time dust is on this thing. It just don't work. Oh, come on. 4x cubed over 3 plus 7x to the 6 over 6 minus 6x squared over 2 plus 2x plus c. Anytime you get a question on integration, you're adding 1 to the power and you're dividing by the new power. You're adding 1 to the power and you're dividing by the new power. Watch me. So this now becomes 4/3 x cubed plus 7/6 x to the 6 minus 3x squared plus 2x plus c. So when you look at the question, and the only reason I wrote a third line is because there was something there that can cancel down. I hope you see that. And I wrote the stuff and then I cancel it out and write that third line. But if there was nothing to cancel down, it's one line I'd use to do the question. Can you see that?
Yes, sir.
All right, cool. I'm going to ask one
Yes,
question.
sir.
Yeah.
For that second line, I see you have the 4 over the 3. Does it have to be that way? If you have 4x cubed over the 3, is that okay?
Yes, it is. Very good. Now, hear me out. I don't want anybody to be sitting down, you know, and struggling. And you know, don't open your mouth and say anything. Because I will call upon you in class for you to work the question with me. So if you're not understanding, and it's not a punitive measure to say I'm embarrassing you. We're a family, and none of that don't go in Mr. Shan's class, eh? I do this because I want you to learn, to learn what is happening. You know what is happening now? Okay, let me just do that and then let me just do it. Yes, please.
Question.
Mhm.
So you're to always add 1 to the power and whatever you add, whatever the answer is that you add to the power, that's what you divide by.
Very good. Very good.
Sir,
question.
Oh, sorry. Finish what you were saying.
No, I was just going to say, in response to Calvita, I was going to say, yes, Calvita, add 1 to the power, divide by the new power. Add 1 to the power, and then divide by the new power. Go ahead now.
Sir, whenever you have a constant by itself, like they have +2, you're always going to put x beside it.
Yes, please.
Oh.
All right. I thank you for that question, Shidi. Really, of course, in my mind, now say, look, coach didn't reach class yet. But watch his checks. You see that 2? It's 2x to the 0. Sir, you are confused the thing now. What is x to the 0? Anybody?
1.
So when I write 2x to the 0, it's just 2 I have there, so you know. Because anything written to the power 0 is 1. So 2x to the 0 is simply 2. Watch me. When I integrate 2x to the 0, add 1 to the power, from kids, look at this. Add 1 to the power, 0 plus 1, divide by the new power, 0 plus 1. 2 to the x plus 0 plus 1 are 1 over 1. Oh, sir, can I write 2 to the x, don't sir? I mean 2x, don't sir? Yeah, just like that. So you see that, Chance?
Yes, sir.
Mm. There's somebody that is not seeing this. Can that person speak to me, please? What are you not seeing exactly with this question? Hello, somebody?
So one thing me kind of not understand, so like the blue writing, what's the difference between the green and the blue?
For this one here, so?
Yes, sir.
Same thing, let's done.
You have the first answer where you have in, sir, when you need to work it out, but I don't really get the difference with the blue writing.
Okay, so what I did, let's done, is just to write 4/3 x cubed, but this one here now is 4x cubed over 3. Same difference. 7/6 x to the 6, 7x to the 6 all over 6. Same difference. And of course, the negative 3x squared plus 2x plus c is the same thing that we have here.
Oh, sir, I think I see it now.
Yeah, man.
Never realized that the line underneath was actually shorter.
Oh, yeah, man, it was. It was. And that's fine, Papa. Thank you for your question, though. Clear up something for somebody else. All right. Now, you notice what Sir did? Sir asked the question, you know. And what Sir do, you know, is when students are not following, I'm throwing away my notes, you know, my typed notes, you know. I'm going to start writing, you know, because as I go along, I'm making up questions, you know, and I want you to do it. So when I put the questions on the board, you already have the questions that I was going to go through tonight. You already have those questions that I sent you from last class. All right? Now, what I want you to do is to understand. I don't know how many of you were able to go through those, but I'm going to go through some new questions with you that I'm generating. All right, now, which one do I write? What if I say 9x squared minus 3x to the 4th plus 5x plus 1 dx. Integrate happening, please. Mhm. All right, so you're supposed to be finished. Anybody still working on the question?
Yes, sir.
All right, cool.
Think me of it, sir.
All right. Aviana finished?
Yes, sir.
Good job. I think you know. We're coming a while ago. Frank Newman. Andrew, B, you all right?
Yes, sir. Almost finished.
Good. Utterly, or you stay? Karika, you all right? Karika. Okay, Karika not talking to me tonight.
Yes, sir. Sir, I'm okay.
You sure?
Yeah.
I prefer you better when you make noise in class. So start talking. Davey, are you okay?
Yes, sir.
Nice job. Monica, get up and go make some tea, honey bunches. I'm gonna sip the tea, but nobody burn up yourself though. Ramesh, you all right?
Still working, sir.
Okay, cool. You're not in a good mood. You're sneaking and just barely say good night and I don't hear nothing from you again. You all right, mommy? Who trouble you? Tell me.
Sorry, it's funny because before I said good night, I was talking to you.
Say it again.
That is funny because before I said good night, I was talking to you.
Okay, thank you, sweetheart. I know I can depend on you. Zidane, you're the first one who joined class tonight. Are you okay, sir?
Yes, sir. I'm okay.
Good job.
I
Thank
think.
you. Yeah. We will find out in a few. Sean Casey Anderson, how you stay?
I'm good, sir.
All right. Shana Lee D, how you stay? Smithy, you all right?
Sir, may I try follow?
I'm gonna try to follow. That's nice. That's all I ask you to do. All right. So I hear from Krishna. I hear from me not call you Jermaine because if me not say nothing to you, you not say nothing to me. All right. Because if you not gonna say something to me tonight, me not call you Jermaine. And I hear from Chedi. All right. Cool.
Good, sir. We're good. We're good.
All right. Nice. Good job. Good job. All right. Let's go. So now we are going to be integrating because we said right and we're integrating now. So when we integrate, we are going to get add 1 to the power divided by the new power. Add 1 to the power divided by the new power. Add 1 to the power divided by the new power. Add 1 to the power divided by the new power. Add 1 to the power divided by the new power. So add 1 to the power divided by the new power. Add 1 to the power divided by the new power. Add 1 to the power divided by the new power. Add 1. Add 1 to the power divided by the new power. Sir, so when you integrating 1, you don't say 1 dx, you just integrate dx. But when you integrate 1, you have to get x plus c. Anything can cancel out here, so I forgot another line. So 3 that goes with 3 times. So we get 3 x cubed minus 3 x to the 5th over 5 plus 5x squared over 2 plus x plus c. Who said that is right?
Yes, sir.
Big
Yes,
up
sir.
Yes, sir.
yourself, sir.
Very
Yes,
nice.
sir.
Very nice. Very nice. I know what I did deliberately. Yes, please. Go ahead.
Question.
Yes, please.
Because kind of do it in my head and get get something like what you say.
Mhm.
But the oh, you get the plus C.
It's a constant of integration. It's
So that
because
means you must always have
yes,
plus
please.
C.
When you have an indefinite integral, and that's all we're doing. So you see what I'm doing tonight? I'm just going to write maybe about 8 more of these questions and just throw at you. And then when I do that, I won't even go into the logarithmic and the exponential ones tonight. I may or I may not. I don't know. I may just change up things and then move into the definite integrals. All right. So I know you weren't here, Kel, but guess what? There's somebody that was here but still don't understand why I have the plus C. So thank you for asking for them. How much was it? Sure. So let us go. All right. So Kelvita live on Lover's Lane. But Lover's Lane is a long avenue. It's a long avenue. She lives on Lover's Lane. Now, when you go and say, you know Kelvita Phillips? Because I own dog, I own him so. I don't know, you know. Nobody not live on here named Kelvita Phillips, man. But you know, say Kelvita live on Lover's Lane. Lover's Lane, it take you a day and a half to walk out Lover's Lane. Right? And you can't find where Kelvita lives. That is what is called an indefinite integral. But guess what? No. Kelvita tell Ryan where she lives. He saw Sir Mix up. And Kelvita tell Ryan, say, on number 15, Lover's Lane, me live. So when Ryan pass by and say, oh, Kels, him can say so when he might drive past number 15. But outside of that, nobody else knows. Number 15, Lover's Lane, is a definite integral. You know why? Because she's definitely residing there. I have something very specific that I know. The indefinite integral could be anywhere. So why I have that constant of integration? Because it could be anything that is out there. It could be any, I don't know what it is. So I'm making preparations for something else that is there. And the preparations that I'm making for my indefinite integral is my constant of integration. Now I need more information. I need more information from Kelvita in order to evaluate what C is. And when I evaluate what C is, now I'm going to get a definite integral. Watch me. And I want you to work with me now, because matter realize something, you know. And if I go to school, teacher, they teach me like how me I teach, you know, maybe I'm that brighter, right? Or not even brighter, but just say bright, right? Watch me. It don't make sense, Kelby, to tell Ryan are number 15 because there is no number on Lover's Lane. None of the house them have no Lover's Lane number. But Kelby can say, my house is the only house that has 2 palm trees at the front and 2 big East Indian mango trees at the front. It's the only place, and it is painted in yellow. Guess what?
No, sir. Blue.
Blue. Okay, blue. So guess what happened now? What is happening is that even though Helvita did not give Ryan a number, Ryan has some landmarks to definitely find out where she lives. And if she says that her house is the only one on Lover's Lane with 2 palm trees at the front, you may have other palm trees here now, but you may have 1 and 3 and 4. So Ryan may say, but oh, this one have 4. Maybe I also should live. No, she said exactly 2 palm trees. So when you look for the 2 palm tree, then the next thing you look for see to see 2 East Indian mango tree at the front. Then sir, oh, you're gonna know East Indian mango tree. If you're coming from Jamaica and know East Indian mango leaf different from Julian mango leaves, you're wrong. And then the house is going to be painted in blue. You can definitely know, say, Kelvita, you stop again and say, Kels, what go on? And she answer, it's definite because you have more information that can evaluate what C is. So Kelvita, the C is that unknown portion. May not have enough information to know what go on with a C there, but I have to make preparations for the C. So I'm going to call it a constant of integration. It is going to be a constant. It's going to be a constant. Now, what is your constant? The palm trees. Because the only way the palm trees are now going to do is unless you kill them. They will always be there. And trust me, palm trees are hard to
Hurricane
live.
blow it down, sir.
No, and guess what? No. And hurricane have to come good. They are good palm trees, not like foreign, where them have sand. And when water come, it wash with the palm tree and all wash with the house. In our Jamaica, you know, when we are planting, we are planting on surface, you know, we dig hole, a hole, and put things in there. It's well sturdy.
Same so.
No, man, not tell you the truth. It's well sturdy. Well sturdy. All right. Right? So that is how we take into consideration this constant of integration. It means that there's something else that is there that I don't know. I need more information to find out. It's just like you go to the doctor and say, doctor, I have a headache. And doctor says, well, you know, you have a headache. It could signify many things. Do you have a fever with it? Do you have this? Do you have loose bowels? Are you vomiting? Are you nauseous? Is the place spinning with you? So there are several things that the doctor is asking, and you are answering these questions. And you know, you want to be as honest with the doctor as possible because you know, it's like I heard a situation where this man is going on a farmer program. Don't know how true it is. It could be for just laughter. Man going on a farmer program, but man smoking something. And you know, if the urine picks up a whole lot of information, and man decides say, oh, him get an opportunity to go up on farm work, him now make film sense mean prevent him from going. Same sitting girlfriend here, the plant them want a urine sample, you know, so you better get a sample for me here, cause me I go foreign. We're gonna make life better for the two of you here. And she said, no man, I mean, real talk, we can't give for you. And the man go to the place and drop off the urine sample. And things say everything curry. And when the man go back for the pick up in paper, he said, oh, I'm sorry, sir, but you are pregnant. You know what happened? They blacklisted him. Period. Because right there and then, they knew that the urine sample wasn't his. Right there and then. And I saw him know same girlfriend is pregnant. Because she never know and he never know. Since the urine test tell him that. What's the point? He needed more information in order for him to supply to them, for them to authenticate what is going to happen. All right? So it's very, very, very important that we do what it is that we're supposed to be doing in order to get the necessary information that we need to process what it is that we have. It's maths. It's a whole heap of investigation we do, you know. As a math student, you're supposed to ask questions. Why think I ask them so much time for ask question? Yeah, man, enough ask question. Ask question. All right, let's go.
Hold on, sir.
Yes, Papa.
Yes, so I've got the answer. I basically just look out for the first example.
Nice.
Work with that. But I'm not really, I'm really understand it still.
Okay, you feel like you don't understand it?
Yeah.
Okay, no problem, Andrew. What don't you feel like you don't understand?
Andrew?
Where's your
This is not Andrew, sir.
Sorry, Lex. Oh, Jesus. Krishna. You may feel that there's favoritism, like they feel that there's favoritism. Yannick, if you open your mouth, Yannick, garden, and say nothing to me tonight, Yannick, I take away lunch money for the rest of the week. Yannick, don't say nothing. Sash, don't open your mouth. All right, thank you. I don't put nothing in the chat neither, right? Krishna, I apologize here, Papa. Go ahead now. You say I feel like you understand, but you don't feel like you understand, eh? That's what you're saying, right?
That makes sense.
Mm.
I think I understand though.
Okay. So what you're going to do now for me, Krishna, is to tell me what it is that you understand, and let us see if that is a true understanding. So what do you understand? Let us look back at the question. The question is projected. Number 2, that is, let us look at what it is that tell me what it is that you understand. Talk to me.
Okay, so based on what I'm seeing, 9x to 2 to the 2 r square. You're going to add 1. It's going to be 3. And
add
then
1 where? To the 9?
No, sir, to the 2.
Okay, so you added 1 to the power. But why you use the jargon, you know?
To the power.
Right, when you speak the jargon, it makes much more sense. Yeah. So you added 1 to the power 2, so you get 3.
And then you're going to put that 3 underneath the 9x.
Okay, that's it.
And that's pretty much how you're going to do it for the rest of them as well.
Okay, so it's press pause.
Okay.
Guys, no, hold up, Krishna. Don't, let's press pause. Let's press pause, Papa. Class, has he gotten it? That was a question.
Yeah, sure.
I'm asking
Except
you.
for the last part.
No. I'm asking you if what Krishna said to me just now, if it sounds like he got it.
To an extent, yes, sir.
Yeah, but I'm right.
Yeah,
so
you
added
add 1 to the power.
And divide by the new power.
Yeah, my brother. You're Chris, I'm correct.
Brother, you're Chris.
And then you add C to it.
And then you add a C to it. Yeah, man, you have to put it.
And if I want, it is X.
If I want an X.
Yeah, man, know that. Yeah, man.
Yeah. So a problem now. Tell me I don't understand now.
No, I understand. So it'll get harder from here, right?
I get what?
Harder from here.
Me not tell you that.
No, it's so simple.
Me not tell you. You think me crazy? You think that me I'm gonna give you my backyard and tell you my pin is 1, 2, 3, 4? Eh? You're crazy.
I'm not gonna tell you, but you tell Charlie.
Sir, please declare up the misconception in the chat.
you know, is it Uno? All right.
Question, sir.
Yes, please.
The one with the divide, right?
Uh-huh.
A question with a divide, right?
Uh-huh.
What if they have, for example, x squared plus 3x?
Sorry, I'm hearing you, Sash. I'm hearing you.
Sir, already know?
No, you see, on a serious, you know. Sash, you asked me the question. Where you talk about Charlene pretty clear iPhone?
Sir, that always a thing about Charlene.
All right, go with the question.
Yeah, so I'm saying with a divided question with division, right? What if in the denominator you have x squared plus 3x?
Sorry. Nika, you're so mean. Jeez on peas. You see, you must go boil 2 cups of tea. Sorry. Go ahead now, please. You need me not pay no money. If I pay you any money tonight. Sash, can you ask a question, please? If you have a division, what?
You're not ready for me, you know?
No, I'm ready for you, man.
Yeah, so I'm saying again, for a question, a divide question, right? For example, number 15 that you have.
Don't go there yet.
You only have x squared.
Yeah, don't go there. Don't go here. Because number 15 is the one with the division sign, right?
Oh, may I jump the gun?
Yeah, jump the gun. Yeah, I don't want to go there yet. I'm getting there, so that's why I didn't want to answer Krishna just now, because I'm getting there. So what we're doing right here is the basis of the integration. It's when I catch you at a point where I know you can integrate, then I'm going to give you some variations to the integration. Not difficult, because once the base is there, you're fine. But if you don't know how to integrate and I jump into something else, you're gonna have problems. So I'm coming there to you. I'm coming. Just hold on 1 minute. All right. So let me give you threats. And I say to you, for example, I say to you 2 minus x plus 3x squared dx. And I want you to start working for me, please. And I give you 4. And I say to you that this is 1 over 2x. No, if I do this, Krishna will say to me that I told him a lie. So let him not do that.
You say sing my name when me never there.
Me for tell you. Okay, so me want to know owner call Charlene name. Listen to the recording.
Exactly,
Every night. Where's Kelvito? Kelvito not coming to class. It's all right, man. I not pay only no mind.
They're directed.
Sir, I choose she never dare for call up Charlene name, say you never for call it.
Same way. So when Kelvita listen to the something, she can come back and say, G's on peace, sir. All right. Well, you have those 2 questions. Start them for me, please. And let us see how well you get through to those. Finish?
Yes, sir.
Krishna, you finish?
Not yet, sir.
All right, I'll give you 2 more minutes. 2 more minutes. All right. So let's go now. So when we are integrating, we are adding 1 to the power and dividing by the new power. I don't know how many of you recognize I'm saying this so many times so that you can remember what it is that I'm saying. That's the only reason I'm saying it so many times, so that you can remember what it is that I'm saying. I'm adding 1 to the power and I'm divided by the new power. Watch me. Adding 1 to the power divided by the new power, so this becomes 2x minus x squared over 2 plus 3x cubed over 3 plus c. And that gives me 2x. And I can call it a half x squared, same difference. And I can call that x cubed plus c. And that's my answer. I choose to write it like that because sometimes you may go into the test and a multiple choice question will not say x squared over 2, but they will say half x squared. So I'm trying to write it in different forms so that you are a little bit more flexible with what is to come. All right? Tell me, did everybody get that as an answer?
Yes, sir.
Yeah, actually got it.
Yes, sir.
Very good. So Krishna, let me hear you again. You got that, right?
Yes, sir.
Very nice. Very nice. Sean, talk to me. What do you get for the answer, Sean? Shana, Smitho, talk to me.
Sir,
Mm-hmm.
sir, I didn't get the half x squared part.
Did you get an x squared part?
The half x squared?
What you got?
Yeah, I didn't get that.
What you got?
I have x squared over 2.
Same difference.
Oh,
Look here, Chedi. You see this piece here, sir? Chedi?
yes, sir, I'm here.
Yeah, man. I'm saying, you seen this here, x squared over 2?
Yes, sir.
Are the same thing as a half x squared here?
Okay.
Yeah, man. So you're right. Sean. Shana,
Sir, I have a question.
go ahead, please.
How did it become plus of x squared?
It's supposed to be a negative a half x squared. Don't you see the negative sign there?
Sorry, your final answer of a plus sign. Sir,
You see a plus sign right there?
sorry, I cannot trick me, sir. What you want to change it?
Sir, I wonder if I'm me, I do much wrong, you know?
You see a plus sign there? No, you tell me no. You see, you have trouble with me in the chat. You see a plus?
Sorry, I better edit.
No, man. Thank you.
Man said not who can notice that.
Yeah, thank you. Here. Thanks.
Come here,
Put it
so
this way.
how
No,
make sure it's close?
I put it there to see if you guys were following.
Sir, would I try
Yeah,
to correct your error?
But just skim through it real quick.
Yeah.
Say that the plus there, like most people think the answer wrong.
No, man, you guys get it, man. Very nice. Very nice. Very nice. Very nice. Lexton, your father named Lexton, don't?
No, sir.
Okay. Lexton sounds like a big man name, if you understand what I mean.
Sir, that's everybody are here.
Old man name, sir. Old man.
Somebody say I have 2 last names.
Yeah, but it sounds like that too, yeah. But you know, it's just like when somebody is named Vincent. Vincent is not a nowadays name. Vincent, one. Yeah. So when I hear Lexton, I was like, he has his father's name. But anyhow, all right, let's go. Wait, you have a grandfather name? Your grandfather name Lexton?
Sir, far from that. I'm the only one in my family have that name.
Okay, all right, cool. So I'll pass it then. All right, let's go. Very good. You notice what I'm trying to do, guys. I'm trying to let the class feel very easy, right? So it's interspersed with different things because this what I'm teaching you is really not difficult. The portions where it's going to cause a little bit more thinking is to come. I really want to build our confidence. So work with me quickly to just understand it so I can put a little bit more, put it into second here because we're still cruising. All right, let's go. Wow. When I'm integrating 1 over x to the third power, what's the first thing that I need to do?
Rearrange.
Reciprocate it there.
Very good. Same difference. You hear the big words them? Reciprocate, rearrange, same thing. Very nice. So what I'm going to do is to let this be the integral now of x to the negative 3 dx. Very good. Then what I do next?
Negative 3 plus 1.
Oh, fabulous. X to the negative 3 plus 1 divided by negative 3 plus 1 plus c, and that is going to be equals to x to the negative 2 divided by negative 2. Add 1 to the power, divided by the new power, and this now becomes negative a half
X 2 x² + c. Very good.
Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good. Very good And that's our answer. Excellent. So it's negative 1 over 2x squared plus c.
Hold up, sir.
Mhm.
Stop the last part.
Yeah.
Last part, you miss.
All right.
That 1 over 2 times x squared.
So recall a to the negative m is equal to 1 over a to the positive m. 1 over a to the negative m is equal to 1 over a to the positive m. So when I have x to the negative 2 over negative 2, that is going to be the same thing as, you notice a to the negative m, I have a 1 in the numerator, so I can put a 1. This negative 2 is in the denominator, so it's going to remain in the denominator. Then this x to the negative 2 is going to go into the denominator and become x to the positive 2. You notice that this is negative m, and down here it becomes positive m. So this is what I have. But this negative sign, if it's in the numerator or the denominator, it still makes a whole fraction negative. So we just rearrange it and just put negative 1 over 2x squared, or you can simply write negative 1 over 2x squared. Then, sir.
So I try, wait, looking.
Yeah, no, that.
You write it weird.
This, I write it weird, or that are all correct, right? It's just that we don't normally put a negative sign in the denominator, but if you have it like this, I won't mark it wrong. But I'm just saying to you, we never normally write the negative sign in the denominator, but always either take it out because there's a whole fraction that is negative, or convenient to just put it in the numerator. But if you have it here, this is still a correct answer. This is still a correct answer. This is still a correct answer.
Question,
all right?
sir.
Yes, Danny.
Will you say what answer?
Yes, dearest.
Oh, so you're working out on the paper, right?
Mhm.
You have x to the negative 1 divided by negative 1.
Mhm.
So C. Then you have negative x to the negative 1 plus c.
Yeah,
And the
yeah,
final answer would be negative 1 over x plus c. I'm trying to wrap my head around this that you do right there.
Okay, I'm not even seeing what you're talking about. Where are you?
The first, working out on the indefinite integral sheet that you gave us.
On a sheet?
Yes, sir.
Okay. Okay. All right, hold on. Because you had me there a while ago.
Or is it because the power is 1? Make it be 1 over x.
Right, because remember now the power, remember when you take this negative, when you take this 2, when you take this negative 2, or when you reciprocate, as the big boss say, or you take it up in the numerator, same difference. It becomes x to the negative 2. And you're adding 1 to the power and divided by the new power, so it's going to be negative 2 plus 1 over the negative 2 plus 1, and this becomes negative 1. I don't want the negative power. We never normally write our answer in a negative power. So we're converting it into a positive power. In doing so, I'm going to flip it in the denominator. So it becomes x to the negative 1, x to the positive 1, x raised to the positive 1, but I don't have to write x raised to the positive 1 because I know that is just simply x, which is this. And this negative sign is this sign right here. So ask me the question again, because I don't know if I get what it is that you're asking.
Okay, I see it now, sir.
Okay, good. All right, good. All right. All right, I'm going to give you 9 o'clock. How are you feeling now, guys? Are you feeling a little bit more comfortable?
Yes, sir.
All right. So allow me a caution. So long may I caution
Yeah,
Jesus.
probably one more like number 4.
One more like number 4, no problem. Ryan, stop come class. The whole class last time I called him and you know answer me. 3, 4, so this is 5. You have to be careful of what you ask teacher, you know.
So true, sir. Next thing I see it in the questions.
I'm make it tell you. Right, no, but nothing more than that. Try that one, please. all of you should be able to complete that one. What do you get for the answer? Oh, what's the first thing to do, Barbara? What's the first thing to do?
Rearrange.
Very good. We're going to rearrange. And then now, when I'm differentiating, sorry, what did I say a while ago?
Differentiate.
Jesus of mercy, Lord, help me. When I'm integrating, you know, you're alert, very nice. When I'm integrating, I'm going to get x minus 2x to the negative 1 over negative 1 minus 4x cubed over 3 plus 7x to the 5th over 5. Be very careful, be extremely careful about this one. There are times you will look at -2 and see a +2, right? You have to be very careful with that. And then what I'm going to have now as my final piece is going to be, oh, plus c. As my final piece, I'm going to have x plus 2 over x minus 4 over 3x cubed plus 7x to the 5th over 5 plus c. And I know for a fact that this piece here should have caught somebody.
Sir, no.
Oh, sir, I never catch me.
Sir, the question
very good.
no, sir, is why in this case you want to bring down the 2 because your side.
It's in the numerator. Very good. You see where that 2 is? Numerator.
Sir, my only difference, well, I got the answer still, but the only difference was I have 2x up the numerator still over x.
So the negative 1?
No, it can't be 2x. It has to be 2 alone in the numerator because remember, let me see if I can find me another color to Jesus straight this one. I don't want to demonstrate it, so let me Jesus straight it and show you what is happening here. You see this negative 1 here is what we're using. Recall a to the negative m is going to be equals to 1 over a to the positive m. So it's going to go into the denominator. And that piece is going to go to the denominator. These are the things that you must have an eye for, because you see when was it Lexon when or one of them, I think it was Lexon who asked, sir, give you another one like this. And you notice I said not a problem, and I wrote the question out without even just putting the 2 over x squared alone, but I gave you something with a whole heap of mix up something in there. Because this question will go for 1, 2, 3, about 4 marks for this question. All right? But quite a number of students would have gotten 3 out of 4 marks for it. Because that term, the 2 over x that I circled, would have been incorrect for a few students. You see what I circled on the left-hand side here with the 2 negative signs? When I divide 2 negative signs, they become positive. When I multiply 2 negative signs, they become positive. Right? Notice, only when I'm dividing and multiplying those negative signs, 2 negative signs, they become positive. So that sign there will have to change now to positive. The 2 is in the numerator. A very good question, Yannick. The 2 is in the numerator, so it stays in the numerator. And the negative 1, x to the negative 1 is the only thing that I'm interested to move. And I'm putting that in the denominator. I'm reciprocating that because we never normally write our answer as a negative power. So those are some of the things that you need to be mindful of. And once you do that, you're good to go. All right. This is 11 past.
So sir, if me
Go ahead.
with the 2x over x, when I get it totally wrong, sir.
The 2x over x would be wrong because when you do 2x over x is really 2 you have, you know, because the x's can cancel. Yeah, so that term would be incorrect.
Is that look
So-
thing I would write there that the 3 lines some would I get marks then?
Sir,
And that's I'm coming to you, honey. And that's the point I was making last class, that even though you notice most of these questions I'm doing them in 3 lines, it is important that we're right, because sometimes, okay, let us look at this one here. This one was 4 lines, because let me just spotlight what I'm showing you. So this was 4 lines. So after I rearrange, I got it to here. You notice I don't start my integration yet. So I won't even get a mark for this, because really I don't start my integration. The only reason why I rearrange is because it's going to make life easier for me to do my integration here. Much easier for me to do my integration. So that's why we rearrange. So you don't even get a mark for the rearranging here. What is important now is that when you integrate each term here, now watch me, Sash, if for argument's sake, you had it correctly over here like this, but when you are transferring the information here, everything here says wrong, but everything here says correct, but it just don't fix up yet. The examiner, the person marking, instead of giving you 0 out of 4 for the question, they may say, let me penalize the student for incorrectly writing the final answer, but let me award the student the mark for here. So you can get as many as 2 marks, and depending on the marker, you can get 3 marks, even though. So what's the point? The point is your methodology, your working out. It is important that you show your steps. Very important, very important that you show your steps. So in as much as I say I don't want to see the 5 and the 6 and the 7 lines like when I just taught you the topic, and I only showed you those many lines because I wanted you to see what was happening as we went along. All the questions we've done so far mainly is 2 and 3 lines. This one is 4 because we did a rearranging or something. Yeah, somebody else was coming in with sir. Hello? Who was coming in before? All right. Let's go. My question to you is, and I really want to answer me honestly because I can step it up a notch now, but I want to get a true answer. Are you all following what is happening here?
Sir,
Yes, please.
sir, I just wanted to break down how you move from the 2x -1, that part, to the 2 over x.
Okay, Trini. All right, no problem. Watch me. This x is this x. Everybody agree with that?
Yes, sir.
All right, good. Trini, unmute your mic and talk to me, please. This negative sign divided by this negative sign gives me a positive sign. Can you see that?
Yes, sir.
Good. Tell me where the 2 there. What's the location of this 2?
In the numerator?
See it right here. So is this in the numerator?
Right. Yes, sir.
Good. This x to the -1, where are we going to put it?
We're going to put the x -1.
Yeah.
And that one.
All right. So I'm
well,
saying to you,
according to the recall.
Right. According to the recall, where part it goes?
The denominator.
Okay, so watch this now. So when it goes into the denominator, what happens to the power? It becomes
negative. Positive.
Right, it becomes positive. So this is x to the -1. So when it goes into the denominator, it becomes?
Oh.
Magic.
So, sir. May sound stupid, but the negative...
No, stop that. No question that you ask me stupid, and no, don't do that. Don't do that to yourself. Hold on,
Okay.
1 minute, 1 minute, Chedi. Hold on, one minute, please. I had a thought a while ago, I just missed it. 1 minute. Oh, and x to the first power is equals to x. So when you say x to the first power, when you say anything raised to the first power, is equal to the power itself. All right. Go ahead with your question. Your very sensible question, no, Chedi.
Okay, sir. The negative one in the denominator. I see where how we change the sign to positive, but where the one goes, it does multiply 1 by the x to the negative 1 that is now in the denominator.
No. All right. Let me ask a question. All right, I'm just trying to find an example, Kirika. I'm sorry, not Kirika, Chidian. Chidi. So you have a foreign exchange account. You have an account with US dollar in there, eh? And you see it. And you have both 5,000 US dollar in there. Now I wish big things for you. You have both 5,000 US dollars in there, eh? And you do your thing. But when you look at it, you know it's 5,000 US dollars. But every day when you check your account from see everything all right, one moment, you see 750,000 Jamaican dollars. And then you say, you know what? I'm bored, I'm gonna check my account. And you go in there and you see 745,000 Jamaican dollars. What do you do?
What I mean, sir? Is that a bank?
Yeah, no, but I mean, you can't go to the bank. The bank will tell you, say, I'm gonna tell you that the dollar fluctuates. So the Jamaican dollar in the course of the day lost its strength, its value. So because it loses its value, when you wake up in the morning and check your account and you see $750,000 calculated at $150 Jamaican to 1 US, right? You see 750,000 Jamaican dollars, but by midday you go check it is 745. So you lose $5,000 because the currency the Jamaican currency loses the money. All right, but the following day you check your account. Let me hear your response to this. The following day you check your account and see $760,000 in there. You got the bank still?
No.
Why? Because of more money down.
Right.
Good. All right. So the point I'm making is you'll have to know how the foreign exchange currency works. And because you don't have the rate of exchange, because that fluctuates periodically. It fluctuates periodically. You don't know what it is. It's not a fixed value. It's not a fixed value. All right. The point I'm making is a sudden match day. The law of indices says a to the negative m is going to be equal to it's going to be equal to 1 over a to the positive m. When you reciprocate it, the power changes its value from positive to negative. You know what is also true? Let me tell you what is also true. Again, put another and. And 1 over a to the negative m is equal to a to the positive m. So it works both ways. If you have a negative power in the denominator, when you reciprocate it, it becomes a to the positive power. It becomes a to the positive power. And of course, that a to the positive power is in the numerator. So it works both ways. So best believe that in Trinidad, them call it chicken curry. In Jamaica, we call it curry chicken. Best believe are the same something. Them use our same Jamaican curry or the Indian curry to make them chicken curry. And it will use me for a curry chicken. It's just a different name at the same something. What I'm saying to you is a to the negative m is going to be equal to it's going to be equal to 1 over a to the positive m. And if I have 1 over a to the negative m, when I reciprocate it, I'm going to end up with a positive power. I'm going to have a to the positive m. That's just how the law works. That's how the law works. And how did we get a law? It's by working several questions and see what it evaluates to be. Right? So if you want to check it, you can put a to the negative, a to the, sorry, not a, 2 to the negative 2. When you put 2 to the negative 2 in the calculator, you see that it's going to be 2, which is equals to 1 over 4. So if you put 2 to the negative 2 in the calculator, you see that you get 0.25. Put 2 to the negative 2 in your calculator and see if you get 0.25 for your answer, or 1 over 4. Chetty, you that, and tell me.
One over 4.
Magic. So you know the law works. And this is why it becomes a law. You know, this is how theorems are formed in mathematics. We recognize that when we do something one time and we do it another time and we perform this procedure many times over and we get the same answer, we call it a theorem. We know it's a law. It can't change. Nothing will change this because I saw it go. It is my story and I'm sticking to it. And that's why it is like that. So tell me that you see it more, Chedi.
Yes, sir.
Good job. Final question before I turn up the gear. Is there anybody else in the class that has a question? Not seeing anything and you want me to try and clarify it? Please speak. No, I don't want to hear that, sir. I was shy. Speak. All right. So, if you don't understand, I am adding some seasoning to the pot. This seasoning contains some Scotch bonnet peppers, the real hot ones.
Sir, me can't manage that one day, no.
All right, never mind. Neither can I, but never mind. Come, let's go. This is not what I wanted to do tonight, but since I'm on this thing, I will just go and then I'll go back to what it is that I intended to have completed. So what I'm going to do is I'm going to go back to my blog. All right, so I'm going to be looking at some definite integrals. Lord Jesus, sir. Definite, so we just look on the indefinite one. So why you have to do the definite one? You couldn't wait until next week. Crazy? Watch me now. I'm writing my elongated S. My elongated S tells me that I'm in integration. This up here is going to be called my upper limit. And this down here is called my lower limit. All right. Inside here, I'm going to have my function, as you'd have seen, integrating with respect to x. So that's what a definite integral looks like. An upper limit and a lower limit and a function. Oh, sir. Yeah, man. So what you're saying with Kelvita now is that when she tells us she lives at 15 Lovers Lane, it is definite. That means that you know where 15 start and stop, the corner house, from one end of our house to the other end. Yes, that's what it is. For example, So my upper limit is 1, my lower limit is 0. The upper limit has to be bigger than the lower limit, hence the word upper. Okay, sir. So are you saying then, sir, that the number up top can never be smaller than the number on the bottom? Absolutely. All right, hold on, guys. Is Ryan in class?
No, sir.
Somebody message him for me now, please. Tell him say don't play with me. Because he wasn't here last class neither, because I'm calling him and he was not responding to me. Just message him for somebody for me now, please. And tell him, say, sir, say don't play with him. And find himself from class. Because he not send me no message for say him have any difficulty. Tell him to find himself from a class here. All right. So we have an upper limit. Thank you, please. So we have an upper limit and we have a lower limit and we have a function. All right. Now, to show you that this definite integral does not deviate too greatly from our indefinite integrals, I am going to ask you in 4 minutes or less, and 4 minutes for those who are still catching the integration, 4 minutes to integrate this function for me, and we'll come back and have a conversation on that. 4 minutes. Start now. Integrate the function, please.
Sir, Charlene said she finished.
Very nice. What about the rest of you? Very nice, Charles. What about the rest of you?
I was waiting on the 4 minutes to say I'm finished.
You know, you're too cute for me, you know. All right, very nice, very nice, very nice. The rest of you, come on, guys. Remember, you know, this not hard, you know. The integration part is not hard, man. Come. Germany finish?
Yes,
Are
I
we on
see the
finish?
1 and the 0.
No, man, don't worry about that yet, man. We soon come with that. Sean Anderson, can you unmute? All right, good.
Yes.
You
Yes,
finish?
sir.
You finish?
Yes,
Charlie,
sir.
not even give me a
Yes,
chance.
sir.
Lexon, where's the water, Lexon?
Charlie, not even give me a chance.
Lexton, I did not say anything.
How much but Charlene said the answer? She just said she finished.
Exactly.
That just smash up my head, sir. And she said,
And when you leave Charlie, you know, all right, because I don't want to sing for Charlie tonight, you know, lesson because say, there you go again.
All right, see there.
All right, let's go. So, very good. Now, I am going to show you. So, all I asked you to do was just to do the integration because I really want you to get the integration, but I'm going to show you what it is that I expect of you. So, you're going to say to me, but sir, my working out is a little different because you never did show me. Don't worry about that. What sir asked you to do was what it is that you did. Watch me now. So, I have this question and then the solution now. The solution is going to be I'm integrating, so it's 2x squared, so it's going to be 2x to the third power and divided by 3 because I'm adding 1 to the power and dividing by the new power plus I'm adding 1 to the power and dividing by the new power. I'm adding 1 to the power and divided by the new 4, that's divided by 1. And then I'm going to have 1, 0. Sir, I never put mine into something like that. Sir, I'm going to have plus c. Ouch. So because it's a definite integral, we are not having any plus c because it's definite. So there's no constant of integration because the function is not definite. All right? So look at what is happening. Look at what is happening. My upper limit, my lower limit is going to be the upper limit minus the lower limit. So watch it. It's going to be now 2 times 1 cubed over 3 plus 5 times 1 squared over 2 plus 12 times 1 minus 2 times 0 cubed over 3 plus 5 times 0 squared over 2 plus 12 times 0. So what I'm saying to you is going to be the upper limit minus the lower limit. The upper limit, oh sir, you're substituting the upper limit into the integral, and then when you do that, you're going to minus it from the substituted lower limit of the integral. Okay, so I get you. Yes, I'm substituting the upper limit into the function, minus, and then the lower limit. So what is going to happen here now is that I'm going to get 1 cube is 1, 1 times 2 is 2, so I'm going to get 2/3. 1 squared is 1, 1 times 5 is 5, so I'm going to get 5 over 2. 12 times 1 is 12, I'm going to get 12. Watch this magic. Minus 0 cube is 0, 0 times 2 is 0, 0 over 3 is 0. The same thing for the other one, the same thing for the other one. Sir, so every time I get 0 as a lower limit, that will happen? No. No. So, oh, so we must add up all of these now, sir. Yes. What's the LCM here? 6. Sir, I'm going to put this over 1. Excellent. 3 into 6 goes 2 times, and 2 times this 2 is 4. 2 into 6 goes 3 times, and 3 times 5 is 15. 1 into 6 goes 6 times, and 6 times 12 is 72. 72 plus 15 is 87, and 87 plus 4 is 91. Double check that for me, please.
Unit 2?
Unit squares.
Squared. So it's not unit squared.
No, I was just trying to write the square up top.
Oh yeah, I was asking why is it unit squared?
Because you're actually calculating the area.
Okay.
Right, so whenever you're doing something like this, you're actually calculating the area. To be honest with you, it's just one other not to put up, you know, because all of you would have gotten, hopefully, the integral as 2x cubed over 3 plus 5x squared over 2 plus 12x. True or false?
True, sir.
Yeah, man, yeah, man, yeah, man. So with that, say it again.
Or do you just replace it with 0?
No, replace the upper limit in there first, minus the lower limit. Yeah, man. So what it is that you're doing, so even if you make a wrong substitution, you will get marks for doing the integration. Because this, so you see what Sir said a while ago? He's stepping it up with a notch, by a notch. So we're still doing the same level of integration, you know. And that's why I decided I'm not going to do what I plan to do tonight and just move on to this one because of the mood of the class and where your headspaces are. So we're still doing the integration, but then know what we're doing, we're substituting the limits into the function, the upper limit minus the lower limit. in order to evaluate what this function is. We are evaluating what this function is.
Sir, question.
Mm-hmm.
You will always have unit squares for your answer.
Mm-hmm. Yes, I'm going to.
And you must always, when you're making the formula, you must always put the upper limit
Minus the lower limit.
minus the lower limit.
Mm-hmm.
Okay.
And that's when you're doing a definite integral. That's when you're doing a definite integral. Now, let me give you Stone. What time class supposed to finish? 10 o'clock, don't?
Yes, sir. 10 o'clock.
Okay.
Terminative, I know what is the time.
No, I mean, to tell you, man, trust me, when you're having fun, it just runs. Like when 12 o'clock came to us, like, what the heck? It feels like 10 o'clock. Anyhow, I was going to save a story until I reach the next topic, but let me just give you a piece of the story now. Sasha's father gave her a piece of land, a country.
Sorry, I read my mind.
But yes or no, the land of Sasha's father gave her a country now. Very rough. It is very hilly and has some very nice limestone boulders, like when you go to airport and you look to the left-hand side and you see them nice big boulders that they use as a groin to keep the water from one side of the road to the other side. Yeah, man, some nice
What, sir?
groin,
Okay.
right? So what the land that her father left her is nice, but guess what? And it's hilly. So Sasha gets a good developer, and the developer says, you know what I would do? I would have blast this, because when you blast the land, you get enough more space out of it. You blast it and you can't go because all of this is bedrock, miss. The wall of done is a solid. And the surveyors come down and say, yeah, man, you have X amount of meters that you can go down, and Sash say, what you say? So that means that we can get 1 3-story building out of it, and then Sash just say, Airbnb, straight. And what's like way up on the North Coast? Sash said, no, man, I'm like, hotel this, man. These are my riches. She said, thank you, daddy. And she blasted stuff. What it is that you're doing is calculating the area pretty much under the curve. But I'm not going to talk about the under the curve part until I actually start showing you some curves, right? So it's pretty much the area that she has, and which is why I'm saying it's unit squares, because it's the area of the plot of land that she can go all the way down in order to do this stuff. Because remember, there's a certain part of it that you can't go down, because by then you're going to find or aquifers, we're going to find a different type of soil, or not groundwater, but you may find different things in the lithosphere, which is the earth part of the stuff that you really want your structure to be able to stand up. So you really want the bedrock part of it, eh? So she decides that here the plan, I'm going to do that. Or Sash may say, the land not big, So instead of getting a 3-story, what I'm going to do? I'm going to get a 2-story, but I'm going to have underground parking. So nobody can have to park on the road. Let me give you a real life situation that is happening now in Kingston. For those of you who live in Kingston or work in Kingston or have to traverse in Kingston, and you can tell me if you agree with me. There is a place right at the corner of Stanton Terrace and Mountain View Avenue. Oh Lord, it was called Priority House. I used to go over there to assess my car. And one morning, I passed there and everything was okay with the building. Matter of fact, it was weeks prior to that I'd gone over there to get my car assessed to pay my insurance. And by the night, when I was leaving night class and I go up on the road, I said, wait, how the place looks so different. And when I look next to him, I said, Rockstone, the building gone. And within a week, all the rubble was removed, and the people them start digging down. Now the fence wasn't up, so I could see them going down and digging down, and them digging down, and them have the tractor down there digging, digging, and some people may wonder why them going all the way down there. Because the plot of land, more than likely, I have not been down there for quite a while, so I don't see what it looks like. It's one of two things. It's either going to be a commercial building or it's going to be residential, right? If it's residential or commercial, they are having underground parking, because you will know that is a main road, Mountain View Avenue, and then I think that one is not Tucker, is not Goodwill. I think it's Goodwill. The avenue that it is on, Goodwill Avenue, I think it's one Goodwill Avenue. Goodwill Avenue is just one straight avenue that, if it's a commercial building, people, you can't block somebody else's gate, so they have to have underground parking. And that's what it is that we do when we integrate. We are finding the area. So they know, and most of the places in Kingston, you may see a residence that is sold, and then when that is sold, you wonder how them get an apartment out of it, and how them get 8 units out of one little something, and each unit is allocated 2 cars. So you talk about 16 cars, and then know them have both 4 or 5 or 6 car space up on top for the visitors. Yeah, man, because you don't have enough car park spaces. Most of the apartments that are being built now in Kingston have underground parking. Most of them. And this is what the developers have to do mathematics, So them find the area, and them can the surveyors have to come in and survey the land to say, yeah man, you can go down 25 feet beneath the surface level, ground level. You'll be fine. So that people can drive down and park underneath. Yeah, man, you have enough space, you can do all of that. As a matter of fact, there's an apartment complex that is being built near me. That, of course, one Sunday after church, we saw them having open house, and we say, yeah, let's see what's going over here. Swimming pool and all. And there is an underground well, because where I live, even though we're supposed to be having natural springs, we have a lot of water lockouts. So what this apartment is being, developers are doing, is building a well inside the basement, the underground parking. So people be parking on top of the something. And then I said to myself, they said, them can't give me this parking lot on top of the well, and me take it. Me say, me not take it. And then when I look at it, I said, but it's going to be very strong. They don't use a regular steel that they use a big heavy duty steel. So when they cover up that, it's good to go. Right? Now, of course, the maintenance for that apartment complex is going to be very expensive. You know why? Because they have to use now a pump to pump the water from the well into your homes, and especially if them have like 3 and 4 story. If you on the top story, they use more electricity to get the water up to you. So the maintenance of that unit for that apartment complex is going to be more. Plus them have swimming pool, it is going to be more. So this is what the developers use. They are able to do them calculations and say, here the plan, yeah man, this can work and that can work, and yeah, we're good to go. It is the area under the curve. And when I get to applications of integration, you will hear me come back to that story. You will hear me come back to that story. So yes, it is the area that we're calculating, and it's going to be unit squares. Fair enough?
Yes, sir.
Yeah,
So are you not up here there rent, Or
and sometimes, let me tell you something. I was watching something just now, and this youth post something to say that in Harborview, the new apartments that are being built just before you reach the center, Harborview Center, the 2-bedroom houses in that in those units for $22 million, right? What is being built for $22 million now? You can hold a bed. You can hold a small dresser or a small chest of drawers. You notice I said a small, or says not both, and just one night table. You can't have,
Sure.
huh?
I hear on the news when yesterday or the night before they're talking about these constructions happening in Kingston. And like some of the contractors, they're doing more than what they're actually legally allowed to do in the small spaces, and then a lot of people.
That's exactly what I mean. So what I'm saying to you, Karika, they are making the square footage so much smaller, but you're paying more for it. You know, like the New York sort of setting. They are high rise, like the one on Route Bend. That is causing a lot of controversy. It is the National Housing Trust that build the place. Poor people's money. People like me and you who are throwing little NHG something because we have to throw it by law, but yet still know when the houses are being built. Me can't afford it because me I want teacher and them houses are go for $26 million. Me can't afford
Sir,
that
if my
$26 million.
points no half the amount what they want.
Which is the point I'm making. That's the point I'm making. But guess what? My 2 pounds is inside of the NHD pool that is being used to build these houses so that the top people then in the country who making far more than me can buy it. It is unfair. So which is why when the public coming out and talking about it, they are correct. Because me and you who are work little and nothing, but giving quality of ourselves, it excludes us. Me going to tell you straight up, I don't think I can be qualified for 26 or 28 or 30 something. I can't qualify. How big them pay a 28 something $million mortgage when they talk about almost $200,000 a month for mortgage payment? Where do we get that from? I'm a teacher. Unless I'm going to be in illicit business, but yet still they are taking money from me as an NHT contributor. But I can't buy the stuff. It's the man them know who have them big job as CEOs and them something they can live there because this is New Kingston. So right there and then them rural people like me and you from even dreaming to live in New Kingston. And it is wrong. So yes, Karika, they are maximizing, and Calculus 2 will speak about maximizing your profits. And incidentally, that contains differentiation again. You have to maximize your profits. So what they're going in to do now, they say, you know what? Look on a space here. We can get 35 units. And then somebody come in and say, you know, if you, instead of making each unit this amount of square footage, you know, you can do this and shave off that. And we can get 5 extra units. And the man say, no, you're right. And 5 extra units at $25 million. 25 million plus 25 million plus 25 million 5 times is enough million, $250 million more, right? So yes, these developers are actually doing a wonderful job for the country because, you know, the country looks nicer. You know, more people can, more houses are available, but sometimes it is exclusionary because some people can't afford it. But the point I'm making in a mathematical sense is that they can calculate the area of what it is that is going to be that you can do it, and it is math. So they have some formulations that they use. So like the car companies, even a normal business like KFC and Burger King, and they have their formulation. How much do they expect to make? So their formulation maybe in the morning they are not going to do fries because fries don't do well in the morning, but people may want hash brown. And sometimes they may say, you know what, to recognize that people know in the morning are asking if they can get fries and hash brown, so them start do more fries in the mornings. But in the mornings, you may not be able to get a fish burger because in the mornings people want breakfast. So in the mornings, you may have breakfast selling more than the regular sandwiches. So in the morning, what it is that you can do is put on more bacon. So it is that when the people then come, the wait time is about 5 minutes or no more than 10 minutes. So you're actually supposing what the customer wants. So it is that you can get them in and out very quickly. Now, when you and I are going to a restaurant to have shoulder steak and lamb, and them something there. You know, so if I go there and they said, oh, would you like an appetizer? I say, yeah, what do you want? Chicken wings, we have deep fried shrimp, we have vegetables, and we have this, because those are already made. But you have to go wait about 30 minutes or 40 minutes or 45 minutes for that lamb to be prepared, because it is a very expensive meat, and they're now going to prepare the meat for sit down and nobody no buy it and it waste. So it's when you come in, they're going to take out the lamb, tie it out, season it, and look after it. It's like them catch the fowl and kill the fowl and look after the fowl. So your waiting at restaurant is going to be longer. And that's why you have to pay the service charge in terms of, we call it, the service charge you have to pay and tip these the waiters and in something, because it's a longer time you're sitting in the company, in the restaurant. So you have to end up paying more. So that's why when you go to places and you spend $32 for a nice little food, and when the food come, you see one ice cream scoop of mashed potato, you see them put piece of banana chips or plantain chips in the middle, and then give you 2 pieces of fish fillet, and when you lift up the fish fillet, you can look through it, and then drizzle it with some nice chocolate, something in the plate, and the plate pretty. But by the time you do one gulp, you inhale the food and it's done. That was $32, because inside of that is the space that you're sitting down and waiting for somebody else who could be occupying that space. So they are making money, right? It's a formulation. Formulation, all right? Now, I'm going to give you one to try on your own. Don't be alarmed. What number was this? 5? Don't be alarmed at the substitution. Oh, that was 1. Move on, something else. So this is 2. So what I want you to do is, you know how to integrate. That much I know. I'm confident now that you know how to integrate. So when you integrate the function, I'm just going to ask you to evaluate it thereafter. I'm going to put this here. So I'm going to ask you to evaluate. I give you an easy one. X squared plus 5 dx. So the upper limit is 2 and the lower limit is 1. Remember, it's going to be unit squares when you finish. So I give you a couple of minutes to do that for me.
So if you get a fraction and you see it can break down some more, can you do that?
Yeah, man. As per usual, yeah, man. I'm not talking because some people may still be working and I don't want to disturb them. So
Sir, guess what I forgot to do? Cheese and peas. I forgot to subtract.
yeah, man, you have to subtract. What you did, you added 13 to the 6, the 38 to the 16.
No, man, I didn't. They were separate still.
Okay. All right. So look at it. Did anybody get that for the answer?
Yes, sir.
Yes, sir.
Very nice. Ask me any question now.
Sorry, can I go through it, please?
No problem. So what it is that we did? What it is that we did was to, so we're given, I'm trying to go up to the top of this thing, but somehow it's not allowing me to. All right, somehow it's not allowing me to go. So you know what the question is. The question was x squared plus 5. We're integrating x squared plus 5, a definite integral. Upper limit is 2, lower limit is 1. When we integrate x squared, we're going to get x cubed over 3. When we integrate 5, we're going to get 5x. So this is the integral right here. The document not allowing me to move up. It is, this is my integration with my upper limit, my lower limit. All right, so remember, it is always the upper limit minus the lower limit. It is always, every single time. Oh, no, you decide to move? Come on, no. It is always the upper limit minus the lower limit. Always the upper limit minus the lower limit, all right? So having integrated, what it is that we're doing is to substitute the upper limit into the function, the integral. into the integral. It is the antiderivative. So anywhere in the antiderivative that I see x, I'm substituting 2. So this becomes 2 cubes over 3. See here, 2 cubes over 3 plus 5 times 2. See here, 5 times 2. There's no other x term for me to make the substitution. So I'm going to now go ahead with the lower limit. But of course, this sign minus sign is always there. It is always the upper limit minus the lower limit. So it's going to be 1 cube over 3 plus 5 times 1. So it's the same thing that we're doing, same function we're working with for the lower limit, or we're doing a substituting different values in it.
Sir, put the bracket around the 1.
Okay, okay, thank you. And then what it is that we're going to have now is I'm just evaluating the function. So 2 cubes would be 8. 2 times 2 is 4 times another 2 is 8. See it right here, so that's 8. Over the 3 plus 5 times 2 is 10. Then, sir, why put it over 10 over 1? Because I'm adding these two fractions. You notice I never use a calculator because I'm adding two fractions. I know how to do my LCM. So I just put it over 1. It does not change the value here. All right? And 1 cube is 1 over 3, 1/3, and 5 times 1 is 5. And I put this over 1 also just for ease of my LCM. In this case, the LCM is 3. 3 into 3 goes 1 time. 1 times 8 is 8. 1 into 3 goes 3 times. And 3 times 10 is 30. Similarly, my LCM between 3 and 1 is 3. 3 into 3 goes 1. 1 times 1 is 1. 1 into 3 goes 3 times. And 3 times 5 is 15. 8 plus 30 is 38. And that is over our denominator, which is 3. This minus is right here, minus 1 plus 15 is 16 over 3. Now watch this trick. Because my denominators are the same, I can do the operations in the numerator and put back my denominator. See, I put back the denominator here, and then I'm going to say 38 minus 16 is 22. So my answer is going to be 22 over 3 unit squares. 22 over 3 unit squares.
Sorry, you lose marks if you leave off the unit square.
Yes, ma'am. You're going to lose a mark if you don't put the unit squares here. Trust me. And that's it.
All right, sir.
Yeah, ma'am.
Not bad.
It's not bad. What I'm going to do, I'm going to send you this document now, but give me a few. I'm just going to stretch it out a little, and then I'm going to write maybe about 5 questions. I won't be able to do the solutions to them now, but I'm going to write about 5 questions just for you to have. And the 5 questions will be on the definite integral, because of course, you know, you have to do the integration first and then do the substitutions. I won't give you any indefinite ones. So I'm going to give you some definite integrals for you to evaluate for me. And then you just do that, I think good to go. That's all right?
Sir, I accept the challenge for you not to have the answer.
Ah, bless up, bless up, bless up, bless up, bless up. All right, guys, remember, you need to say your gentle Jesus before you go to bed. Get some good night's rest, and all the best.
Thanks, sir.
Yeah, man, bless up.
Bye.